So what I would like you to do is come up with your own. Okay, so I'm going to draw a random triangle here, right triangle. Now you need to choose something different than mine, but I'm going to maybe go 4 this way, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go 4 and 9. Okay, and I'm going to connect that diagonal here. Okay, so there's my right triangle. I'm going to use that 4 and 9. So I'm going to 1, 2, 3, 4, 1, 2, 3, 5, 6, 7, 8, 9 to get the corner. Okay, so be very careful of how to count up the coordinates to get the corner. So it's good. We're going to switch to X and Y. Okay, make sure you count accurately. So I'm using 4 and 9 to get the corner. So I'm going to use 9 and 4 this time. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Okay, and notice that triangle, I could have drawn it the other way. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way, we're going to get that corner. And that corner allows me to generate the square. Okay? And you can see now that if I kind of draw in these lines here, you can see the triangles that make up that square. It's going to be the same as this right triangle here. I'm just going to highlight it. Okay, this is my 4 by 9 triangle. And that same triangle shows up on the outside there. Okay, so the relationship that I'm looking for here is the square off of this side. So this is going to be a 4 by 4 square. So that's a 16. There's 16 squares here. And this is going to be a 9 by 9. So 2, 4, 6, 8, 9. Okay, so this is going to be, actually I should do this in red since it's down below as the colors are red. Okay, so here's my 4 by 4 square. Here's my 9 by 9 square. Okay, so this is going to be 16 and 81. So this is going to be 4, 9, 16 squares, 81 squares. And we are getting 97 squares in red. Okay, so we want to see that the C square is going to add up to 97. Okay, so let's count this up. This is going to be 4 by 9 divided by 2 is going to be 18, 18, 18, and 18. Okay, the square in the middle is going to be a 9 minus 4 square, or a 5 square, or 25. Okay, so let's add that all up. So we get 36, 72 plus 25. Yeah, there's 97 squares in that black square there. So C squared is 97. Okay, these are equivalent. Okay, the length of side C works out to be square root 97. Okay, it's just a little bit less than 10, so 9 point something. And again, notice that these two side lengths, 4 and 9, do not add up to 9 point something. Okay, the side lengths are not related. What's related is, and the picture kind of shows that, is that these three areas are connected to each other. This square and this square seem to be able to fit into that square. And that's what our Pythagorean theorem is saying. Okay? And again, this is not anything like a proof. Okay, we haven't proven this, but it certainly seems that a squared plus b squared equals c squared. It seems like it works. So we're going to start using this calculation to help us with these areas. And we can find these areas, but more importantly, what ends up happening is we can use these areas to find these three side lengths. Okay, now we need to still square root. Okay, we need to go from area to side length to be able to do that. But this now allows us to find these lengths of these sides. In particular, the length of this diagonal line, which is not a very easy number to get. Okay, because for one thing, it's that diagonal. We can't count along the grid anymore, and it's not necessarily a nice number to calculate. Like in this case here, square root 97 is a really, really messy number. But this relationship allows us to calculate that length of that side.